Okay, today we are starting on our next unit, which is on three-dimensional figures. And I'm going to try and pop kind of back and forth between the notes and a few IXLs as well. And I posted one or two just to kind of refresh your memory. You have seen some of this before, but as I've always mentioned, we're upping the difficulty level a little bit. So first of all, a polyhedron is a three-dimensional figure. And it is made up of three-dimensional figure consisting of polygons. Okay, and the main thing you have to remember with a polygons has to have straight edges only. Straight edges only. And we'll look at a few of these here in just a second. So with regards to our figure here, this is considered a polyhedron because all of its sides are polygons. Specifically, they're either squares or they're rectangles. Well, this point right here, that's referring to that connection of the two, what we call faces, and that is called an edge. And that is the intersection of two faces. And then all of the sides of that polyhedron are called the faces. Those are the flat surfaces. And as I said, in polyhedron, those flat surfaces have to be polygons. And then if you can see, each one of those corners is what we call a vertex or a vertice. And like I said, kind of informal would be the corner. So let's go take a look at a few figures and see if they're polyhedron, and we're going to look at also what we call the net of that figure as well. So taking a look at a few of the IXL, what shape is this? This is a cone. This would not be considered a polyhedron because it doesn't have edges, or I shouldn't say it's not made up of straight sides, it's made up of a circle. So that one would be a cone. Okay, this one we know is a sphere, so again, this would not be considered a polyhedron. A cylinder, again, this would not be considered a polyhedron. Okay, this would be considered a polyhedron because each one of those faces are consistent of polygons. We know that would be a cube. This one right here, we know this is a pyramid. A pyramid we'll look at a little bit later consists of where all of the faces, or most of the faces, are triangles. Again, that would be considered a polyhedron. Let's go look at one more. This would be considered a polyhedron because, again, all of its faces are consistent with polygons. That would be a rectangular prism. Okay, let's flip back to our notes then. Okay, there is a specific formula called Euler's formula that relates the faces, the vertices, and the edges. That formula is F plus V equals E plus 2. And if you look at your formula sheet, it is on there as well. So if we look at this specific case here, so the number of faces, so again, that would be all of the four sides here in the top and the bottom. That would be 6. The vertices are those corners. So you've got 1, 2, 3, 4 here, and 4 more down here. Would be 8. The edges we said are all of these straight connections of the faces. So if you notice, you've got 4 around here, 4 at the top, and 4 at the bottom. That would be 12 plus 2, and confirming 14 does equal 14, so it checks out. So let's go down and look at a few examples. It says if we're looking for the number of edges, we know there are 6 faces, so we're going to plug that in. We have 8 vertices, and we are looking for the number of edges, so we're going to leave that blank. So we have got 14 equals E plus 2. That means we end up with E is equal to 12. Okay, let's go look at another one. It says we're looking for the number of edges on a polyhedron with 8 triangular faces. Okay, I'm going to change this second example. I'm going to give us the following. This would be considered a rectangular pyramid. And let's suppose we have to find the number of edges in this. And again, we're going to use the formula. So let's go ahead and put it down. You've got F plus V equals E plus 2. There are a total of 5 faces. You've got the 4 triangles up here and then that base. Vertices, there are 1, 2, 3, 4, and 5. And we're looking for the number of edges. So we have E plus 2 is equal to 10. So there should end up being 8 edges. Let's count them out. There's 1, 2, 3, and 4. 1, 2, 3, and 4, and we verify that. Okay, I'm going to pause for just a second. Let's go look at a Math Excel related to that. Okay, let's look at a few of these. Is this a polyhedron? We said this would be no because it has a circular piece to it. Is this a polyhedron? Yes, because it has all sides are polygon. This would be a no. Okay, now we've got a few that hopefully entertain this, some of the vocab. He made a 3-dimensional figure out of wood. The figure has a round base. Which figure would it be? So it looks like it would just be that cone. Again, all polygons. Okay, this figure had 6 edges and 4 faces. So 4 faces means there's only 4 flat sides. So I'm thinking it would be this one. You've got the 3 at the top and the 1 at the bottom. And if you count the edges, there are 6 as well. So let's go ahead and do that. See if there's one more maybe. That's not really related to that. Okay, you get the basic idea. Okay, now let's go on back to your notes. The second part we're talking about is what we call a net. This is considered a net. It is a 2-dimensional figure that when you fold it, when folded, you end up with that 3-dimensional figure. And again, just to help you with some naming, this figure right here, this is a prism because the majority of the sides are rectangle, and we call it a pentagonal prism because its base is a pentagon. So pentagonal prism. Okay, so for the next one, they want us to draw a net for the figure, label the base, and show all the dimensions as well. So what I'm going to go and look at is I've got that base right here, which is my square. Each side of those are 8. And when I unfold it, I've got each one of those triangles that they said is isosceles. And I'm trying to draw these the best that I can as they're congruent. And you've got 10 on each of these. The base of each of the 4 isosceles faces is the side of the square, which is your base. And again, just to help us name, this would be called a square pyramid. Again, it's called a pyramid because the majority of the sides are triangles. It's a square pyramid because the shape of the base is a square. Okay, moving on to number 4, it says the drawing shows one possible net for the graham cracker box. They want us to draw a different version of that as well. So I see the base down here is 14 by 7, so I'm going to go ahead and draw that. And then I'm just going to unfold it. So that would be the front of the graham cracker box. that would be the back of the box. So this is 14, this is 7. Looks like this length is 20. I'd have to make sure I include the top of the box as well, which again is another 14 by 7. And then I can unfold the right side of it, and I'm kind of running out of room over there with the left side. And again, this would be 20. So our ultimate goal in this unit is to eventually find the surface area. And the surface area is how much space is each one of these all together. So let's go ahead and look at the surface area of this particular one. The first thing I'm noticing is the front and the back of the box, which would be here and here are the same area. So I've got 2 of those and they are 20 in height, and I need to go look at this length right here, which would be the 14. Then if you take a look, you've got the top and the bottom of the box, and those are the same as well. So if I go find the area of just one of them, so this is 14 by 7, and then again I would multiply that by 2 to get the total area. And then I've got the left and the right, and again they are the same. They are 2. This length right here is 20, and this length right here would be 7. So let me go grab my calculator. Plug those in. That would be the front and the back were 560. We've got 196 here. And then those sides are 280. So finally, that total surface area is 1,036, and that would be centimeters squared. Okay, let's go take a look at the last one. It says identify the net. Is the pattern a net for a cube? If so, name the 2 letters. So in other words, if we were to fold this, do we end up with a cube? And the pattern does, but the pattern creates a net because you can fold it to form a cube. And it kind of walks through, if you fold squares A and C up, so those 2, that would form the top or the front and back of the cube. D would be the right side, E would be the top, and F would end up being all the way over here. So they want us to picture which ones match up. So the back and the front would be A and C. Let's go do the right and the left. That would be D is on the right, and F would be all the way over there on the left. And that finally leaves us with B and E are the bottom and the top faces. Okay, again, let me pause here. I'm going to go grab a quick IXL to show you a few more examples. Okay, so let's go look at a few of these right here. It wants to know if the following which will make the figure. So if you look, the bottom of that figure is a square, which would correspond with this one. So we'll click there, hit submit. Okay, looks like this one is a rectangular prism, so that would correspond with this. Okay, so if you take a look at this one, we looked at this one, it's a pentagonal prism, so I'm looking for which one of these has a base that it's a pentagon, which would be there. Okay, they want us to visualize if we're looking at the front of this, so we're standing here, which one of these do we see? Looks like that one. If we had to go and do this one, it says if you look at the object from the top, which one will you see? It looks like we've got 5 by 5. And I don't know if we can, let me move this down. So that would end up being here, but it says we've reached our limit. Okay. Okay, the last little piece that you're going to see on the Math Excel tonight is something on called a cross section, and really it's just an exposure piece. I didn't have any set examples on the notes, but I thought I'd look at a few here. A cross section is though you start off with the figure, and then you slice it down the middle. So you've got this triangular prism, you're slicing it down the middle, and they want you to think about if you turned and looked at it, what shape would you get? Looks on that particular one, you'd get a triangle. So again, you start off with this, looks like it's a, does it tell us what it is? It's a tetrahedron.